Okay, welcome to video 2 of this series on epithelial transport and transport of organic substances. We're going to talk about transport of organic substances in this particular video. So there are a few generalizations that we can make. You should recognize that huge amounts of organic nutrients like glucose are filtered in the renal corpuscle, into the Bowman's capsule, and that a lot of the time, huge amounts of these are reabsorbed from the tubular lumen back into the body because you want to retain them, like glucose. And that does take energy, and it is mostly in the proximal tubule of the nephron. So it takes place pretty quickly after filtration. Okay? Some generalizations here. Transport is usually active, and it usually is some sort of a coupled transport with sodium. So remember, we're setting up a sodium gradient across the apical membrane through the sodium-potassium ATPase in the basolateral membrane. That ATPase in the basolateral membrane lowers sodium in the cell, and then the sodium will be transported from the lumen into the cell, and usually that transport will be coupled in some way to the movement of these organic nutrients. Okay, there is a transport maximum. That is, there is a maximum amount that you can transport, and once you exceed that, then you can't transport any more into the body, and the excess ends up in the urine. And we'll talk about that a little bit in a minute. And there is some specificity, but note that it is not perfect specificity. There are often several molecules that can be transported by the same transporter. For instance, closely related amino acids might be carried by the same transporter. Okay? So having said that, let's start with glucose transport as a really good example of how this works. So once again, here is our figure, here's our renal tubule, here's our interstitial space, and this is the basolateral membrane, this is the apical membrane, okay? And you should recognize, again, like most of these molecules, the reabsorption of glucose is in the proximal tubule. It is freely filtered, like many of these molecules, and therefore a lot of it is filtered. You know, pretty much you'll find the same glucose concentration in Bowman's capsule that you'll find in the plasma. And virtually all of glucose is reabsorbed transcellularly, and normally you will find no glucose in the urine, and if you do, that is a very bad sign. It can mean diabetes, and very often does mean diabetes. And I'll explain why that is in a minute. Okay? But remember, normal urine does not have glucose. You are reabsorbing virtually all of it. Okay? So, once again, we have our 4 steps. Please ignore that sodium and chloride. Now we're talking about glucose transport as a variation of that sodium and chloride transport. So we start off with the sodium-potassium ATPase that's transporting sodium out of the cell, keeping the sodium concentration low inside the cell. And here we have for glucose a glucose-sodium symporter. So sodium goes down its gradient from the tubular lumen to the inside of the cell, and glucose is transported along with it up its gradient to a high concentration in the cell. All right? So we have a co-transporter here where you're using the sodium gradient to transport glucose. And then, so that is our variation of step 2. And then step 3, as usual, is a passive transport across the basolateral membrane. And in this case, you have glucose going down its gradient from high concentration to low concentration through a glucose uniporter. So this is facilitated passive diffusion. And then step 4 is bulk movement of glucose from the interstitium into the capillaries. Okay? So that's a variation of our sodium chloride transport, all right? This should really say sodium and glucose transport. Notice that this is a process with a transport maximum. So these transporters, this one in particular, has a maximum beyond which, it's working as hard as it can, it's working at its maximum rate, and it's transporting as much glucose as it can, but you've hit the maximum and you can't transport anymore. So most transporters have a transport maximum, and it is often relevant to what you see in the physiology and the pathophysiology. So this is a typical example of how that transport maximum works. Again, glucose is a wonderful example of this. We have on the x-axis the plasma glucose concentration, milligrams per mil. Okay. And we have the glucose filtered load in on the y-axis. Okay. And so as the plasma glucose goes up, you can see from the red line, the amount of glucose filtered goes up, okay? The dotted line is the amount that's actually reabsorbed, okay? So, and then the blue dashed line is the amount that's excreted in the urine. So a normal glucose concentration about 1.2 or so here. What you find is that virtually all of the filtered glucose is reabsorbed, and you can see that the amount filtered is the red, and the amount reabsorbed is the dotted line here. They're superimposed because you're reabsorbing all the filtered glucose, and that's normal. Okay, and if you reabsorb it all, then nothing ends up in the urine. But you'll notice that we do have a transport maximum here. And once your plasma glucose gets to about 3 milligrams per mil, you hit the transport maximum. And this is a point at which you're transporting as much glucose from the renal tubule into the interstitium as you possibly can. Okay? And you can't transport anymore because the transporters can't handle anymore. And once you get beyond that, with something like diabetes, where the plasma glucose goes up beyond that threshold, what happens is you get a bunch of glucose that's filtered that can't be reabsorbed. This is the amount reabsorbed, it's plateaued off, and everything between here and here is excreted in the urine because you can't get it back into the body, it ends up in the urine, and that's what this blue dashed line is, okay? So with a condition with high glucose concentration in the plasma like diabetes, you can only reabsorb so much of your filtered glucose and the rest is excreted, okay? All right, so this is a typical example of a transport process that has a transport maximum and what that can mean to you. Do note that as you keep glucose in the tubular lumen, once it gets beyond the proximal tubule, the stuff that was filtered and couldn't be reabsorbed is still there. That increases the osmolarity in the renal tubule, which means that not as much water will move out of the tubular lumen. In other words, your osmolarity will be increased, so you'll retain fluid in that tubular lumen. Instead of being transported out of the tubular lumen, you'll end up with a really dilute urine because you'll be keeping that water in with the glucose, or at least you'll end up with a large volume of urine. And so you get polyuria, and again, that is a typical symptom of diabetes. Urinating all the time because you have a large volume of urine, and that's because you've increased the osmolarity by keeping all this glucose in the tubular lumen. Okay. All right. Why don't we stop there, and then I'll finish up with peptide reabsorption and then urea transport in the next video.